Surroundings here, it's your unified teach. Let's go to the lesson. 9th Standard Science Unit-9 Universe 9.1.3 Stars. If you haven't subscribed to our channel, subscribe now. Click the bell icon for notification. 9.1.3 Stars. Stars are the fundamental building blocks of galaxies. Stars were formed when the galaxies were formed during the Big Bang. Stars produce heat, light, ultraviolet rays, X-rays, and other forms of radiation. They are largely composed of gas and plasma. Stars are built by hydrogen gases. Hydrogen atoms fuse together to form helium atoms, and in the process they produce large amount of heat. In a dark night, we can see nearly 3000 stars with the naked eye. We don't know how many stars exist. Our universe contains more than 100 billion galaxies, and each of those galaxies may have more than 100 billion stars. Though the stars appear to be alone, most of the stars exist as pairs. The brightness of a star depends on their intensity and the distance from the Earth. Stars also appear to be in different colors depending on their temperature. Hot stars are white or blue, whereas cooler stars are orange or red in color. They also occur in many sizes. A group of stars forms an imaginary outline or meaningful pattern on the space. They represent an animal, mythological person or creature, a god, or an object. This group of stars is called constellations. People in different cultures and countries adopted their own sets of constellation outlines. There are 88 formally accepted constellations: Aries, Gemini, Leo, Orion, Scorpius, and Cassiopeia are some of the constellations.
This kinesthetic activity models the life of a large star that is many times the mass of our Sun. Each person involved in this activity represents a bit of the material that goes into making such a star. As the activity begins, everyone is dancing or moving around freely, just bits of matter that are hanging out in some particular spot in space. As these bits of matter come close to one another, they start clumping together more and more due to gravity. After a while, this matter is clumped tightly enough to form a star. In our activity, the participants at the edges form a ring facing inward, as the outer shell of the star, with their hands raised to represent the inwardly directed force of gravity. The participants in the center face outward, representing the core of the star, with their hands also raised to represent the energy generated by the fusion of hydrogen at the center of the star. These two forces remain in balance for most of the star's life. We call this a main sequence star. Eventually, the star runs out of hydrogen to fuse in the core, and the balance of gravity and energy from fusion is broken. When this happens, gravity wins, and the participants in the core of the star drop their hands and move slightly closer together. The participants in the shell never lower their hands, as gravity is always in effect. The slight decrease in the size of the core makes it hot and dense enough to start fusing helium. The participants in the core raise their hands once more as energy is again being generated at the center of the star. Participants in the shell take a step outward to represent the surge in energy, making the star larger than it was during the main sequence phase. The star has become a red giant. Eventually, the core of the star runs out of helium to fuse. When this happens, the participants in the core once again drop their hands and move slightly closer together. Like before, the decrease in core size makes the core hot enough to start the next level of fusion. The participants in the core raise their hands once more. Participants in the shell again take a step outward to represent another surge in energy, making the star even larger. With the largest stars, this process repeats several more times until finally the core of the star is made of iron. This time, when the core runs out of fuel for fusion, the participants at the core drop their hands and once again move closer together. But this time, there is no next level of fusion, as fusing iron actually takes energy instead of generating energy. The force of gravity wins out, and the participants in the shell move inward as the star begins to collapse. As this happens, the core gets denser and heats up, so the participants in the core give one last big push as they move even closer together. The participants in the shell move inward, hit the core's final push of energy, and rebound, exploding out into space in what we call a supernova explosion. This shell material is now available to be used in the formation of another star. The remaining participants from the core now get as close together as possible as the core collapses in on itself. They represent the neutron star or black hole that is left behind.
Let us see about the solar system on the next video. This video is available in Tamil on our channel. If you like this video, please like and share. Please comment below. Subscribe to our channel. Click the bell icon for notifications. Thank you for watching. See you in the next video.